Okay, so the first thing we're going to discuss, oops, I think it's underneath here. Sorry, right here. There we go. Number 1 and 2. It is the greatest common factor, and I probably should have put some space in between here. Okay, so if you open up, you should see 1, 2, and then 3, 4. Another way we abbreviate greatest common factor is a GCF. So I'm just going to explain what it is in the summary first, and then we're going to apply what it means to each example. Your GCF is basically just the largest monomial. So it's a variable in a letter, or just a variable, or just a letter. So when I'm talking about a monomial, I can be talking about a number, or I can be talking about a letter, a combination of two. But it's just one term, okay, that divides in each term. So you kind of have to know your multiplication facts to pick your greatest common monomial. So it's your largest number or letter that can be divided in each term. So the way you break it down is you look at the numbers first, because those are your coefficients to each term, each variable, and then you look at the variable, the letter, to see if you have anything common. So like the first thing I do is I look at 2 and 42. What is the greatest common factor between them? It's just 2. If I'm thinking about my 2 has factors 1 times 2. My 42 has factors 1 times 42, but then 2 times 21. So 2 is the one they have in common. That's what you're using, the one they have in common. Then you look at the letters. I have an X and a Y. They're different, so there's no letter that they have in common. So that means the GCF is what we're going to divide each term by. We're going to divide each term by 2 and then simplify. The 2 that we're dividing by goes outside the parentheses. The remainder, or the simplification, goes inside the parentheses. So 2 divided by 2 just comes out to be 1x, or you can just simplify it as just x. And then 42 divided by 2 is 21, and then your y. So when you simplify using GCF, you're just dividing each term by their greatest common monomial. I look at the numbers 4 and 24. Usually I start with the smallest one and I just say, can 4 go into 24? Can this 4 go into 24? Yes, it can. So my greatest common factor with my numbers is 4. Then I look at my letters. I have an x to the 4th and an x to the 3rd. Since they're both x's, I take out the smallest one. The smallest one is x to the 3rd. So my GCF here is 4x to the 3rd. That's what I'm taking out of each term. I'm dividing each term by that amount. So I'm going to put the 4x to the 3rd outside the parentheses, and then the remainder inside. So when you have exponents here, we have to the 4th and to the 3, you just subtract them, okay? So the 4 cancels and we're left with x to the 1 power. Or you can just say the 1 is invisible, just x. 24 divided by 4, that's going to leave me with 6. And 3 over 3 would cancel out. So that is my final answer. Move my parenthesis in. 4x to the 3rd times x plus 6. So you can think of it as reverse division, or reverse multiplying, excuse me. You're thinking to yourself, what am I multiplying to this 4x to the 3rd to get 4x to the 4th? So anytime we divide like variables and exponents, you just subtract them. Okay. So 3 is kind of more like what we see on Alex. Look at the numbers. Between 8 and 6, the GCF is 2. And then look at your variables, 8 to the second power and AB to the second power. So the smallest between the A's is just an A, which was this A right here. And the smallest between the B's is just the singular B. So we're going to divide each term by 2AB. So that 2AB is what's outside the parentheses. 8 divided by 2 leaves me with 4. Then 1A, and then the B's will cancel. Minus 6 divided by 2 will leave me with 3. My A's cancel. B to the second minus divided by B, which is minus B, leaves me just what? 1B. And that's our final answer. So I want you to try 4, and then let's check it in class. Like, I want you to see if you can find the GCF. Focus on your numbers first. Always look at the smallest one. And then smallest letter. Okay. Smallest letter, smallest exponent. I know they both have x, but the smallest one is just x, not x squared. And they both have a y. And the smallest one, oops, I should have been going to green. It's just the single y. So hopefully we got our GCF. I thought I wrote this down. Did I write it in the wrong spot? Is a 4xy. We're going to divide each term by 4xy, hopefully. So if everything cancels, like the 4 cancel, the x cancel, the y cancel, then you just leave it with 1. Oh, that's what happened. Now, this is your first step. When factoring, you always take out the GCF. That's why this is the first tab. You check for that first, and then we go into our special cases. Okay? So our first special case is dealing with, on example 5 and 6, trinomials. So trinomial means 3 terms. Okay, so we have 1, 2, 3 terms. And this is when we're looking when the first term or the coefficient of the term is 1. So the way this works. Okay, so I'm just gonna, you look at basically the last term. Because this would be our A. That's ax squared. This is our B. And then the last term is our C. So we focus on the C. Okay. So we want to find multiples. So I'm just gonna multiply and add. Well, I'm looking multiples of the last number, which is 18. Well, if I list them, that would be 1 times 18, 2 times 9, 3 times 6. Those are all my multiples of 18. But we want them to add up to the B, meaning always the middle number. So we want multiples of 18 that add up to 11. Okay, so if you look at this, that would have to be right here. This 2 and 9. This 2 plus 9 gives me 11. So I'm going to circle these two. These are the ones we're going to use. Those are our factors. So whenever you have a trinomial, your factors, factoring is dealing with multiplication. So really, these are our 2 parentheses. And the numbers I circled here, 2 and 9, are what go in the parentheses. So this would be x plus 2 and x plus 9. And there's our factors. If our trinomial does not have a coefficient in the front, so all we have to do is focus on the last number. So we want it to be factors of 14 that add up to the middle number, which is 9. So I'm just going to list my factors. Some of you might know your multiplication mentally, then you could go straight to the combination. So 14 is 1 times 14 and 2 times 7. Those are only two numbers that give me 14. And then this is the one that works because 2 plus 7 equals 9. So those are the factors that we're going to use here. So we're going to have m plus 2 and m plus 7. 2 times 7 gives me 14, and 2 plus 7 gives me 9. They have to hold both to be true. Okay? All right, so on 7 and 8, the thing we have to pay attention to is the sign here. Okay? We still want factors of 8, but the sum is a negative 6, because there's a minus right there. So my factors of 8 are still 1 times 8 and 2 times 4. But then I also got to think of, because we're talking about negative 6, I can do a negative 1 times a negative 8, still have a positive 8, and a negative 2 times a negative 4, and still have a positive 8. And that's the pair that gave me a negative 6. So my factors are y minus 2 and y minus 4.
No, because it's multiply.
You multiply first and then you add to see it gives the middle term. Anytime it's a middle here, the only two things that can happen is if they're going to be both negative or one positive and negative. So if I look at this last one here, the last term here is a negative 15. The middle term is a plus 2. So if my last term is negative, that means one has to be positive and negative. The only way I can get a negative 15 if one is plus and one is minus. It's the only way I can get a negative 15. Okay? So did anyone see it right off the bat? Which numbers give me negative 15?
5 times negative 3.
Yeah, 5 times a negative 3. A positive 5 times a negative 3 still gives me negative 15. And a positive 5 plus a negative 3 gives me 2. When you add them. So the 5 is the positive one. So that means W plus 5. And 3 is the negative one. So that means W minus 3. So when you have a trinomial, this is only when there is no lead term with a coefficient. Okay? So when A basically is 1, here we want factors of C which is the last term, that add up to B, which is your middle term. All right, this same concept works with the next one, but we have to notice the difference here, okay? So we still have a second type of trinomial, which is, I'll go back. I'm sorry. Okay. Okay, so the difference on 9 through 12 is now we're gonna have a coefficient. We're not gonna have an a. So now you have a number in front of the x squared, okay? So if you look at number 9, I'm gonna go up. That number, the coefficient of y squared is 3. So the way we do this is I go slide, slip and slide or whatever. So you take this number and you multiply it to the number on the back, okay? So the first thing we're gonna do is say 3 times a negative 15. This gives me a negative 45. This is what we're factoring now, okay? So like that table I did, I want it to be factors of a negative 45 that still add up to the middle term, which is 4. Yes. Now, because it's negative, right off the bat, I know one is going to be positive and one's going to be negative. That's the only way you can get a negative product. So this would have to be a positive 9 and a negative 5. Okay? Because this adds up to be our 4. Now, after you slip and slide this multiplication, when we factor, we're going to divide. We have to reverse the multiplication. So we're going to start off writing the factors like we did on the other set of examples, which is y plus 9 and then y minus 5. But because we have this coefficient of 3 right here, you have to divide each factor by that 3. Huh? Yeah, just a number. And you simplify it. So like, for example, I know 3 can go into 9. So this simplifies to y plus 3. 9 divided by 3 is here. 3 cannot go into 5. So the way this works is this bottom number has to go back up to the front. Okay, so this becomes 3y minus 5. Okay. Because we're looking just for the factors, this works because 3 times negative 5 still gives me negative 15. And then when I do my full, this together would give me 3y. And then a negative 3 times 5 is 15, and that would give me that 4y. So these are your factors. So take your coefficient, slip it down to the back, and multiply. So 2 times 3 now gives you 6. You want factors of 6 that have a sum of a negative 7. This would be negative 1 times negative 6. Because the negative 1 plus a negative 6 still gives me negative 7. So x minus 1 and x minus 6. And then we're going to divide each number by 2. 2 cannot go to 1, so we just bottom comes up. The bottom number goes to the front if it's not divisible. So this becomes 2x minus 1. 2 can go into 6 3 times, so I simplify that to x minus 3. All right, so let's look at 11. Take this negative 5, multiply that to negative 1. That gives you a positive 5. Oops. So we want factors of 5 with a sum of 6. Well, that's easy. What's the only factors of 5? 1 and 5. We're done. All right, so our factors are m plus 1 and m plus 5. But because we had the coefficient, you're going to divide everything by that -5. All right, so this -5 can go in, so bottom up. So this becomes a -5m plus 1. This can be simplified as m minus 1. Okay, so I want you to thank you. Try the last one, and then you're gonna turn in your Flipbook. So I'm gonna check number 12, and I'm gonna check that you have the other 2 tabs completed. Huh? Yeah, that if there's no number, that's like a 1. Yeah, that's like a -1. So yeah, in this thing right here, we should have -6 and a -1.
Yeah.
Yeah. All right, I'll let you try that.